Hi everyone. I am co-founder of Twigg, and before I tell you what Twigg is, I'm really happy to see this community and be part of it. And it's great to be here and presenting to the community. I got introduced to Lib P2P by Manu, and it's been really an eye-opening thing for me. Uh, with the context that I've spent, as Manu said, that I've spent a lot of years building with the state governments in India, building things like farmer registries for 8.6 million farmers and enabling data pipeline and data-driven governance across the states, creating protocols for sharing of data between public and private organizations, creating AI-led chatbots for farmers, etc. What I learned from DPI space is that architecture is the policy, like how you store the data, how you route it, and who can read it. Those are not everyday technical choices, but those are broad governance choices and principles on which the products are made. And if we get them wrong at that scale, it's not a bug, it's actually a crisis of trust, and it takes years to recover from it. Uh, I have a couple of co-founders who are experienced in financial space as well as fintech, building in fintech space, building payment infrastructure with Stripe and Stitch Money. That's who we are, the three of us. The problem that we are solving is a global problem where we have seen that people across the world are struggling to manage their money well. This is I'm talking about even the people who are digitally active, formally banked, but still are making consequentially financial decisions which are essentially not good for them. There's multiple research that has happened across UK, US, India, where the data shows that the system is not working for the generation. It's almost misselling them a lot of things. With Twig, we want to create a financially intelligent infrastructure wherein wherein we read the person's financial picture. We bring in their bank accounts, investments, insurance, credit in one place. We surface pulse score across 20 dimension, and our agentic AI then tells you what's wrong with it, what can you actually do, and how can you do it, and ranks it corresponding to the feasibility and risk. So think of betterments type of models where planning depth is there, and Clio kind of accessibility and habit engine like a Duolingo. So those are the three things we are combining. Now, as a product, we want to go from diagnosis to informing the user to making them learn what is wrong with their finance, and then choosing the right financial product, helping them choose the right financial product, and then subsequently execute on those advices. There are 5 modules that we have built till now to get the data, unified data for the users, to create 20 plus signals on top of it. A conversational AI bot which tells them where they can ask anything and get advice. A filter for influencer noise. So there are a lot of reels, there are a lot of YouTube shorts, there are a lot of TikTok videos that are floating around to understand if they are factually correct, if they are relevant to your situation, and what should you do about it. And finally, a Twig loop model, which rewards you on every good financial behavior that you do. So that's the product that we are building. Now, here the problem that brings me back to what I learned from DPI. And we have a couple of models that are coming up. Transaction classifier, financial planning engine. Given we want to target global audience, we have to take care of multiple concerns like data sovereignty laws. There cannot be a centralized data lake where we can bring in all the data. So we have to manage somehow the model quality. We have to also take care of user trust. We have to also do regulatory compliances, and we also need to have explainability at every step. So conventional fintech that we have seen builds on prioritizes one of this and is not able to take care of all of them. And that's where That's where we feel that libp2p plus IPFS combination can be leveraged, and that's where we are working with Manu and Abhinav to crack this problem. Now, what specifically, at least what we have been able to get till now, is three things. I think the federated model training, which Abhinav would be also showcasing today, that is a very interesting piece where we are not bringing all the financial data of user in one place. Rather, it is a federated learning model training is happening simultaneously. There is a verifiability on model versioning because we'll always keep updating our models. So which means that IPFS CID addresses that with every version that is releasing, and we are able to explain why we said something to someone. And then also the native residency, which means that some laws are there which don't allow the financial data to move out of the country. We are also able to take care of that in a multi-geographical scenario. And I think composability is very, very important for agentic system, and that's overall tying all of it together. Yeah, so yeah, that's where we are. We are working with Manu and Abhinav on this. We are we had started with India, but as to prove something or to as a proving ground. But given the scale of the problem, we are also constantly looking at global markets. I'll request Abhinav to show present the prototype that he has built till now on federated language. That's it from my side. Thank you.
Hello everyone, I am Abhinav. We built this platform at an eGlobal hackathon. Here we can do the training of machine learning models in a decentralized way over a peer-to-peer network. Let's see. So for a training session, we need the data set and training script. So for distributing over the P2P network, the data set is being divided into 3 chunks. And along with the chunk data set, the training script is uploaded to decentralized storage. For decentralized storage, I am using Agave and IPFS in parallel for demonstrating purposes, but either one of them will work. So the data set and training script is being uploaded to the decentralized storage. And yeah, so the upload is done. Let's see how the content hashes look like. So this is the content hash of Agave, and this is the content hash of IPFS. We can use either one of them. Now let's see how the P2P layer looks like. The P2P layer has been built using Python implementation of libp2p, and the gossip submodule is being extensively used. So we have 4 nodes in the P2P layer. First is the bootstrap node, with which all the nodes in the network will connect to. Next, we have a client node. This will act as a proxy for outside users who want to get the training done. Next, we will have 2 trainer nodes who will participate in the training sessions and carry out the training. So there is a connection between all these 4 nodes. All these 4 nodes are connected, are subscribed to a topic fedlearn. On this topic, all of them will receive notifications about new training jobs. Now let's send in that notification. You see, a new the trainer nodes received a new notification. A new training session is starting in channel 101 here. This is all happening using gossip sub module. So now let's join in channel 101. So in procedure with joining to the channel, the trainer nodes will also have to connect to a node which is subscribed to channel 101. For that peer discovery, we are using the gossip sub mesh of the bootstrap node, which basically knows about every node as it is connected to all the nodes. So you see 2 trainer nodes and a client node is subscribed to channel 101. Now let's start the training session. Now you see with this command, I sent the data set and the model to the client node, and it found that the data set is chunked into three parts. Now it will assign these 3 chunks among the 2 trainer nodes and send them the chunks. So you see, as we have 2 trainer nodes, one of the trainer nodes will receive two chunks. So this is the trainer node that received two chunks. So you see, after the training of the chunk, the weights are computed, and then the weights are again uploaded to decentralized storage, Akave and IPFS. You see, this is the content hash of Akave, and this is the content hash of IPFS. Now, these content hashes, there will be 3 content hashes corresponding to 3 weights, as there were 3 chunks. So now these content hashes can be sent back to the outside user, and they can fetch the weights and feed it to their model. So this technique would significantly reduce the training time with as many training nodes joining in the training session. So let's see how the weights look like. So we can just query the thing. Yeah. So this is the latest. So these are how the weights look like. Now the outside user can just fetch these weights and feed to their model. So this application would be particularly practical in training lightweight small language models, which it does not require much fine tuning and work on low infrastructure edge devices. So particularly in the healthcare and clinical industry. So this was the demonstration. Thank you.
Thank you so much, Abhinav.
Thank you so much, Abhinav. This is great.